All right, hello people. So today we are going to be simplifying radicals. Radicals are these dudes. Sometimes it's a square root like this. Sometimes they have a 3 in it. Sometimes they got a 4 in it. It doesn't matter. Either way, it's called a radical. Today we're going to be exclusively working with square roots. But yeah, let's try it out. Steps say, number 1, break down the number inside of the radical by factoring. Okay, cool, we can do that. I'll take a look at 12 down here. When I say break it down by factoring, I mean find two numbers that will multiply to give you that 12. Anything will work as long as it's not 1 and itself. We don't want any ones or the same number, mostly because that's just going to lead us down a hole and there's like too many things going on there. So we're going to avoid those as best that we can by picking two numbers that are not 1 or the number itself. You could do 6 and 2, you could do 3 and 4, doesn't matter. I like 3 and 4. So yeah. Then we're going to break this down even further if we can. So I'm looking at 3. I know 3 is a prime number, so the only option for factors are 1 in itself, and I don't want to use those. So I'm going to stop there for the 3. But the 4, I can multiply some more numbers together to get 4. I know 2 times 2 will give me 4. And then looking down at these again, I'm noticing that these 2's are prime. I can't go any further than that, so that is going to be the end of my little factor tree here, because it's got branches. All right, cool. Got that down. Broken down as far as we can go. Step number 2 says, take out factors that have a matching pair. Okay, I can do that. I see a matching pair of 2's right here, so those will be my pair. And then that means that I can take it out, like it says. So when I say take it out, I mean I can write one of these 2's on the outside. And then I am going to leave any numbers that I didn't use or didn't circle inside of my radical. So looking at this, I see I have a 3 here. And I'm noticing that I have a 4, but this 4 is not going to count. And that's because we've already factored it down here with these two 2's. So this 4 has been used up. That is not part of my list of numbers that I haven't touched yet. But the 3, though, this 3 is left over because the 3 hasn't been circled. It hasn't been broken down. That 3 is going to be left inside of my radical, like so. All right, so let's try another one. Let's do the same steps on, let's do 50. Okay. 2 factors of 50. I know 5 and 10 will work. Again, there are more. Are there more? Yeah, there are more. I like using these ones though, so that's what I'm going to do. Cool. I'm looking at this. I'm seeing that my 5 is prime. I can't factor that any further without using 1, so I'm going to leave that alone. But my 10, I can factor further. I know that 5 times 2 will give me 10, and that works. Cool. 2 is prime, 5 is prime, so I can't go any further than this. This is the end of my tree, so I'm going to move on to step number 2, where it says take out factors that have a matching pair. I'm looking at this, and I see that these two 5's match each other. And then I have this 2 that's left over. Again, I am not going to use this 10 because it's already been broken down. I've already used its pieces down here. So when I go to write my answer, I'm going to have a 5 on the outside because that's my matching pair. And then all my leftovers, by all I mean my 2, that's going to go inside of the radical this time. Cool. Now, sometimes with these, you can actually take out more than one number. So let's check out number 32. Let's see, 32. I know 4 times 8 will give me 32. Both of these could be broken down because I know that 2 times 2 will give me 4. 8, I know that 4 times 2 will give me 8. And then again, I'm looking at this, I see another 4. That could be broken down as well. So I'm at a point where I just have a bunch of 2's at the ends of my branches. So I can select more than one pair since I have more than one set of 2's. This means that I can take out a 2 from this and from this. So when I write my answer, I can take out 2 and another 2 from that second circle. And then any leftovers I have, which again is a 2, will stay inside. And then I could rewrite this answer using step number 3 where it says multiply any leftovers. Here are my leftovers. I'm going to say 2 times 2, that's 4. Square root of 2 still stays. And that is my answer for that question. So sometimes you could take out more than one piece. Sometimes you could take out 3 pieces. Depends on what you have. But that's what we got. Okay. With that being said, I'll leave those other 2 questions to you. And then we can move on to the bottom here where we're simplifying by radicals. And I forgot to erase everything, which is super cool of me. It's fine. But with these, it's much the same. You are trying to find pairs that you're looking for here. So let's take a look. I have x squared. All right. Well, x squared is going to mean the same thing as x times x. So, again, this is us breaking it down by factoring. We're trying to look for a pair here. I see I have a pair. So when I write my answer, since I only have one circle of those, I'm just going to take out 1x. And since I don't have any leftovers, I don't have a radical to write. So really that is my answer. I'm already done with this question. So let's try that again. Let's see. For this one, I have 1, 2, 3 x's. I'm looking for pairs, so I want 2. Looking at these 2 right here. And it seems I have 1 left over. So I'm going to write 1x on the outside and then keep one of them inside since it doesn't have a match. Let's see. I got 1, 2, 3, 4 for this one. I'm looking for pairs of 2, so I got 1 here and 1 here. So I'm taking out 2 x's for this one. And you know, we've already said that x squared is the same thing as x times x, so I'm just going to write it that way, make it smaller. That's what I got. So let's see, 1, 2, 3, 4, 5. I got 1, 2 sets of x's here with 1 left over. So I have x squared, like we said in that last answer. Write that again. There we go, x squared. And with 1 left over. Let's see. 1, 2, 3, 4, 5, 6. 1, 2, 3 pairs. That is going to be x times x times x. It's the same thing as x to the 3rd power. So basically with these, you are counting how many circles you have. Since I have 3 circles, I would have 3 for my exponent. Since I had 2 circles here, I would have 2 for my exponent. I got 2 circles here, but then I have 1 left over, so I have the 2 circles on the outside, and then the 1 that's left over on the inside. Cool. Now, sometimes with these, we may have other variables involved. That's typically how it goes. So with these, you're just gonna do the same thing, but you want to only count the pairs. 1, 2, 3, 4, 5, 6, 7, 8. There we go. We just want to count the pairs of the same numbers or the same letters. So like I have a pair of x's and then I have 1, 2, 3, 4 pairs of y's. So since I have 1 circle of x's, I would have 1 x. And then since I have 4 circles of y's, I would have y to the 4th power. And that's the idea. All right, cool. Last thing that I want to talk about was our practice for these. Now, typically when we see these problems, they're going to be a mixture of both the numbers that we need to break down and variables. And the way we do that is just one piece at a time. So something like this again, 6x to the 4th power and y to the 4th power. I'm going to break down my 6 first, and then I'm going to break down my x's, and then I'm going to break down my y's. So let's see. 6, I know 3 and 2 will give me 6. I am seeing a problem here, though, because I can't break down either of these any farther. Both of those are prime. And I'm also seeing that these are not a match either. So what that is telling me is left on the inside of my radical, I'm going to have 2 numbers. Since I can't match any, I can't take anything out, everything is going to stay inside. All right, so that's what we got for the numbers. Let's try the x's now. I got 4 x's. So 1, 2, 3, 4. I have 2 pairs of x's. So I know that on the outside, I'm going to have x squared. And let's see how many y's we have. 1, 2, 3, 4. Same thing. I have 2 sets of y's that could come out as well. So when I go to write this, I know that I will have x squared because I have 2 circles of x's, so I'm writing a 2. Then I have 2 sets of y's because, again, I have 2 circles of y's. And then inside, since my 3 and my 2 are not circled, they are just going to stay in here. Much like on the other page, when we went to look at our leftovers, if we had 2 numbers, we could just multiply those together. So I'll have x squared, y squared, with the square root of 3 times 2, which is 6. And that will be my final answer. So again, you're just handling them separately. All right, cool. I will leave the rest to you. I hope y'all have a good day. Let me know if you have questions. Bye.